Hello and welcome to my talk about using containers on the HPC system at NHR at FAU. My name is Lukas Schröder and I'm part of the Bayern KI team here at the NHR, and this is the agenda. At first, I want to introduce you. So why do you want to use containers and what are the upsides? Then some container basics. What are they actually? How does it work in the background? Then the most important part, of course, how can you set up your own environment using containers? So starting with a fresh container or utilizing existing containers, especially you might know Docker is the most used one or the most famous one, how you can, for example, use them also on our systems for another software. And then at the end, some troubleshooting and best practices. And of course, that's time for you to ask some questions. First, the introduction. Why? The first argument is you have portability and reproducibility. So first, one main goal is you can bring your own environment. So inside a container, you can set up something like an OS, or I'll explain it closer. So you have way more freedom inside. And on the other hand, you also have then less dependence on software that is present on clusters that we have. Additionally, it is then packed as one file, and this file can be easily copied and also works on other systems that use, for example, obtainers. This means the distribution is also easier. And on the other hand, you have, as already said, an increased flexibility. So system packages you cannot install on our clusters by your own. You have to ask the admins. You can install inside the container. You can also get a feature that it comes close to root access called fake root. And also, as said, you can build it on your own device at home, test it there, and then say, okay, I want to use now the cluster hardware and copy it to our clusters and run it there, or copy it to other clusters. So one example, or why this is now also a current issue on our systems, is that a lot of, especially AI people, use Python pip packages, and to use them, you use virtual environments usually, or Conda environments, and these create many, many small files. And these small files slow down the system in general, because when you load many small files, this takes way longer and takes down the performance of the storage system. So what would be a solution? So if you were there for the HPC Café on February, where it was about handling many small files, you might remember one sentence from there. Would you rather carry 1,000 puzzle pieces with or without a box? And containers, the container approach is to build a box for your environment. So you build one big container where all your environment is set up. This is just not Python files. You can also increase it to other libraries, programs, and so on. And these files can be then loaded very fast because it's one big file. And then the next motivation is because you should. We in our systems encounter increasing problems with Python conflicts itself. So you need, for every new project, you need a virtual environment basically, and also increased file count. So for this reason, on newer clusters, Python modules will be removed sometime in the future. And additionally, there's already on Helma, for example, a limit of inodes, so number of files you can use per group of 500K. So has any one of you encountered slowdown or something? Yeah, okay, I see at least some hands go up. So this is one way to improve this and also give something back to all other users. So what are containers actually? These containers are OS, so operating system level virtualization. So due to the operating system visualization paradigm, this means we have one shared kernel, but you allow multiple isolated user spaces to exist. This is in contrast to other approaches where you, for example, would virtualize the entire host OS. So programs that you can run inside of the container, for them, it's like they run on another operating system. For them, it looks like it has its own file system, a container. It has its own packages installed like you do. Or you can use the external libraries that are there on the user file system and the module load system and bind them. And then the difference, as already said, is this shared kernel. So they still use the kernel that is installed on the OS. So the container system used here on the systems is Apptainer. It's an open source container application, and it's optimized for HPC system. The development began in 2015 as a project at the Lawrence Berkeley National Laboratory as named Singularity. Today, it's part of the Linux Foundation, and its name is Apptainer. It supports InfiniBand, which we use on our clusters, and Intel OmniPath. Also important for our clusters, you can hand through PCIe devices like GPUs, of course important for Alex and Helmer. Then also you can use OpenMPI. There are two approaches to use it that will be presented later on, and together with SRAM, it's integrated into Slurm. So now that's one discerning quality of Apptainers compared, for example, to like the usual workflow with Docker is what is the storage concept. So one container file that is built, .zip file, is immutable afterwards it was created. So this means you have to think in that way that you put every programs and, for example, also files inside the container that you don't need to change. And this means, on the other hand, you want to use the host file system to store files that you change regularly. So, for example, again, the comparison with the Python length is you build your Python length, put it into a container, but the files that you change, that you work on, are still on the file system, and they can be mounted towards the container. So you still maintain your home directory and so on, but the programs live inside the container. They see the files, but they run in the container. This also means there's another concept called sandboxing. There you have an open file system of the container. It looks like a new OS file system, basically, which starts in the folder that you opened it. It is mutable, but the issue is it itself contains many small files. So these are just used for building your system. So you want to ideally build them on your own system or tempdir, then pack them into one .zip file and remove the files, because then you haven't solved an issue if you have, again, many small files. And yeah, that's what I said. After development, you usually... and after development, that's if you do production software and so on, you can pack also the code that you have worked on inside the container, and then you have an easy way to share your program and make it easily runnable on different clusters or for different people. So that's basically known from the Docker concept. Anyone who likes to make its software easy developable, upload it to the Docker, and then everyone can use it. Apptainer has also different libraries that you can upload the files to, and so on. So now to the step, how can you set up your environment? First, an overview. So there, as already introduced, there's the interactive development. That's by using these sandboxes. So you build a sandbox, then you have like an operating system, file system already there. You can enter it, then install your software and package at the end. You build then again one file. Then you can build it from a recipe. So this is called here my.dev, a definition file where you say what should be done during building your Apptainer. And then you also can, the most simple example, just use a container that is in Docker that will get automatically converted to the Apptainer file. And when you have your container file, you can execute it with one, where you run a predefined run script. You can use shell to open the shell inside of the container, or exec to execute a special command. And you can also share it by pushing it to some kind of library. So now a very simple introduction, the easiest way to start. Just Apptainer pull Docker, then it downloads from this website, it downloads this file, and then you can execute command cowsay moo, and then it works. So this is the smallest example there is. For building a container interactively, as I said, you can use the -- sandbox, then you specify your container name and what base container you use. You have to specify always a base container. Later, I will also talk about what would be the ideal base container to use in what case. This can be, for example, Ubuntu, which is just the bare bones structure, or you can use already like PyTorch or already set up environments that has everything that you want. Then you can enter the sandbox that you have installed with the writable option. Then you enter the container as it would be the operating system. I also talk about some flags you can use then additionally. And then there are commands with the build where you can transform your sandbox, which is all the files scattered around. There we are back to our 100 puzzle pieces, back to our box. So with these commands, you can from one end to the other end translate it. And make sure that's an issue I encountered, if you build your container interactively, and then you want to install some Python packages inside of your container, it still mounts your home directory if you use aptainer shell to the container. So this looks like you're using your file system, and you could install the packages also in your $home and not inside of the container. So make sure if you use sandboxing, for example, to use a flag like contain, this means that you will only see the container file system. And of course, because you have many small files, which is not the idea behind container, you should delete your unpacked sandbox afterwards. Then it's probably the most used case is with a dev file, where you first, with Bootstrap, you write from where do I pull my container. Usually it's probably Docker. Then you should use the Docker Hub because it's unlimited in bandwidth to download your container. Then files. So files that are needed during building have to be specified. So during building, your container doesn't see your file system. In this case, it's a simple file with requirements for pip packages. Then you can set environment. This is just for example, if you want to specify some listen port, that's always present when you set it inside of the container. Then there's the post section. There you can run basically anything that you would also run if you set up a new computer system. In this case, because we use the Python base container, Python is already present, so we don't have to install it. So in this case, you have just to write pip install and the requirements. And then there's a run script. This is when you don't use aptainer shell or aptainer exec. This is when you use aptainer run. You can already specify a script that does things. So the most easy case, for example, if you have a program and a config file, you could, for example, say already run my program with this config file. And then only thing your user of your container needs to do is to type in aptainer pull to download the aptainer, and then aptainer run to run the commands that you have already specified.
I have a question.
Yes.
You go back to the
Sure.
If I know that Python 3.10 is available on the host system already,
Yeah.
I know that's not a good idea because I want to stick to that version and I want to avoid version clashes. But in principle, I could reuse any software that's installed on the base system also from the container.
Yes, but then you have to bind it. You have to set it up in the way in the container that it knows where your Python installation is. But in theory, you could, but you shouldn't. But I'll also go about this with the CUDA issue. So you can basically, with mount, that I will present later, bind anything inside your container. And then if you set the according environment files and set it up correctly, you could do this. But then you destroy the idea of a container. Because if you want to send it on another system, where the Python lies somewhere else, then you have problems.
Well, let's say I have a data set that is available on the system in a special directory.
Yeah.
That's like terabytes. I don't want to put it in a container.
Sure. Yeah. So the idea is basically to put like only your runtime environment inside. I mean, you could also combine it together with your data set. Then everything is nicely packed. Or during runtime, you can basically say use this and this files from outside. So, but I'll show this. This, for example, is a bit more elaborate case, but it's also code basically made for copy and pasting. If you already have like a Conda environment, you can extract your Conda environment information to the environment.yaml. And with this script, as you see, the post is a bit longer. it uses a space container, the mini forge container, which is also a good point to start if you want to use Python. And then with this way, it already copies the name and so on and installs your conda environment in this way and automatically runs it every time that you start it. And then for spec, for example, here you see probably more easily that setting up a container is like setting up an OS. So in this case, you can install packages with DNF, which you obviously cannot do on the cluster without admin rights. So this is a way you can install packages like you would on your home system, and then you clone your Git environment, for example, with spec, and then you have it installed. And now to the options to running a container. One is exec, where you can execute a command. Then there is start a shell inside my container. So your shell becomes like the shell on the OS that you have installed inside of the container. But your file system is set up in a way that it still starts at $home on the user file system. So for you, it looks like you are in the file system that you are used to, but the programs run inside of the container. And then you can set, when you specify a run script inside of the definition file, you can just use run and it will run the script automatically. Then there is probably the most important option is bind. Then you can bind, for example, opt or data, or in our cases, the A NVMe, H NVMe workspaces to the obtainer. You can also bind multiple things, and I'll also show how to bind MPI files later on.
So this means, I know Docker.
Yeah.
So compared to Docker, there is pre-configured like arms, whatever it's set.
Yes.
But isn't this a security issue? Because if you get the routine somewhere else that has access to all of your probably security sensitive issue. Because it runs as you as a user of the container, or is it some neutral user?
I don't know really what you mean with neutral user, but yes, in theory, every program inside of the container has access to.
The question is, well, that's the container, then it has to be the same user. It's just not.
Yes, it's the same user in this way from outside. But if you run it
Isolated like in Docker, right? You could explicitly set this up if you wanted to.
Yes, that will be this one here, contain. And then you can run it like Docker. Then you're only restricted to the file system inside. So the idea of the obtainer, or how it's set up here, is more closely like installing a program, some sort of, than installing an entire OS. So obtainer also offers encryption and whatever, you can do more stuff with it. But usually you should think what you install. I mean, if you install some kind of package and software that you don't know, then it's an issue. Okay, so back to the bind. You can also bind multiple stuff. Then there's the fake root, as already said, that you can, inside the container, it gives you root rights. So there is still, if you run it without the fake root, the programs inside the container cannot do everything inside of the container. You have to give it the fake root rights that it looks like as your root user.
What would be a use case for that? I mean, I cannot change what's in the container anyway while it's running. So for that, I don't need root because I couldn't change it anyway. Something like in /user.
Yeah.
So what's the use case for that?
So basically, I don't know if there's another use case, but if you use sandboxing, basically. I mean, you can use it also with execute and shell, but yeah.
So in the building phase.
Yeah, mainly used in the building phase. Might be some point where you use it afterwards, but I don't know. Then contain, again, that you like in Docker. So you only see the file system, which is helpful, for example, if you use the sandboxing. So if I try to run a sandbox, I usually use fake root and contain, because then it really looks like I am installing the system and I cannot mess up some files I have in my user space on the host. Then there's --h, where you can define your home directory, which is usually on this server bound to $home. And then there are some additional GPU features, but on Alex on Helma, the NV is automatically loaded. So ideally, you shouldn't think about it. Then there's ROCm for AMD GPUs. And if you use some special NVIDIA container type, you might use NVC CLI, but that's a bit advanced. So this is just an example from what I actually use from a Slurm script for data parallel Python machine learning code. So it's like a usual batch script. I use 4 GPUs, for example. Then I export where my container is, where my code is. Then I set some parameters that I'm interested in. I go to my directory where my Python code is. And then there, if you want to use it, so data parallel, I use srun where I specify the number of GPU and the tasks and so on. And then how you start srun, and srun starts on every system one Aptainer that I have built with Aptainer exec. There you can also specify directly some environment, which is the same as in the def file where you specify the environment. So for the Python DDP, you need to tell it how many GPUs, what is your master port, and so on. Then I also bind the workspace of Elmar to it. I'm not sure if it's by default bound, but I got some errors. I want to execute my container path. I want to tell it what container it should use, which I specify here. And then at the end, there's the real command that I want to execute on every GPU. So here I have Python, my code, main, and how many layers, and so on. And the distributed is for this. So this is an example how to use on multiple GPUs. So basically, the only added stuff compared to if you use Venv is this red Aptainer stuff. So then back an overview, what was presented now. First, the interactive development with the sandboxing, build from recipe, directly pull from Docker. Then the 3 options, how to execute it, and then sharing. So, and now let's come to the troubleshooting and best practices. So how many people of you are already using, or what environments do you use, and how many do you use? So if there are some Python users, you, for example, 5. Okay. Yeah. For you, it could also be an option to use containers compared to Venvs if you have slowdowns or anything. Of course, it depends what environment do you have and how many files do change. So when I have to compile something, it also gets a bit more complicated than using Python, where you already have this concept of virtual environments. So now, an additional information, Aptainer caches containers that you pull, and these can be quite big. And without changing the definition, they will get stored in your $home, which is not a good idea because it will fill up fast. So you should change it. For example, $work, or if you build on nodes, you can also store it on Tempy. I don't know if that's useful, but don't store it in your home where your space is very limited. You can, for example, also use workspaces. And to make this change persistent, it's useful to add it to your bash profile or bash RC. Then, usually from time to time, it's also useful to clean your cache. There are some options. You can say clean the cache from the last days that my often used containers are still there. Then force and type, where you can what type of the cache you want to delete. So if you run up in problems, think about, I have a cache in my home, I should delete it.
Sorry, what is the cache actually used for? Is it in the building phase or in the running?
It's in the building phase. In the running phase, it doesn't use any caching.
So in production, I won't need it. I just use the container.
Yeah. You don't need it, yeah. So now is the question, when I have a project, what should my base container be? So let's start with some examples that we have already seen. If you use Python at Conda, you should basically, the go-to solution is use Miniforge. Then if you use any CUDA programs, you could try binding our CUDA setup inside of your container, but we encountered some issues with it. So the best solution is to use an NVIDIA container, which already has the CUDA driver installed. In this way, you can also test different drivers. So my advice would be, if you depend on CUDA, look at some libraries that already are, base containers that already are built for CUDA usage, because binding it can be problematic, yes?
I was thinking that the container is particularly in ISOs, so easy to test using that driver. I would think that installing the driver would require some requires. Or replacing the driver with a different.
So as
The host operating system for the GPU is still running. You cannot just remove the old driver. I want to get my head around how this works. So is it just the libraries or really the driver?
Okay, yeah, I'm not sure with the at least the libraries, but I think, or what I've heard is that you can also use different CUDA versions.
You can use
So probably not the driver, but different CUDA versions work.
different CUDA versions is no problems. And if you cannot bind mount or automatically mount the CUDA driver from the host using the NV switch, you have to exactly match the driver version from the host in your container. Otherwise, it will not work. So if, for example, on tiny GPU, you want to run Red Hat 8 based container, you cannot bind mount stuff from the host because of 2 new glibc versions on the host. Then you have to rebuild your container with the NVIDIA driver itself and have to update the container anytime we do an operating system update or install new NVIDIA drivers on the host.
I hope your question is answered.
Yeah, so it has to match. You have to hard code which driver is running on the host, basically.
When you use the binding, yes. Then one other idea would be Ubuntu or some other distributions. That's very small. I've looked up the space. If you just build Ubuntu container, it's like 100 kilobyte. So it's very small. So if you want to the greatest degree of freedom and set up everything for your own, you can start just with any distribution and then install just the packages that you need. And this way, your ZIF file will also be the smallest and kind of the most efficient, but it's more work to do. So what are our tips, recommendations? The highest chance that something works out of the box is basically if you choose the container which already has the program that you use installed. For example, I use QPy, which is a special version for CUDA optimized numerical code and I tried to install it on Ubuntu or already CUDA container, but ran in some issues and would have had sometimes setting everything up correctly. So I looked up, there is already a container from the developers, so I used this one. So that's probably the easiest and hassle-free way to use the container that's closest to your project. Or if you like to spend time setting up everything, then you can use the base container, more simple base container. And also if you pull from a project, for example, it's usually will have some example files or readmes and so on, like when you would clone the Git repository already inside of the container. So this makes it also easier if you want to get documentation and so on, which is then stored already inside of the container. Then there are some problems when using our server running on Ubuntu. So you will get containers have to be built on a system where you have enough permissions and the security models allows it. Containers that can be built on Alma Linux. So for example, Fritz, Alex, Helma, Woody, and Maggie work out of the box, but they're on TinyX or on the test cluster, there can be an issue. There you get this error. When you get this error, you should use a script that is provided at apt singularity and Aptainer wrapper, which uses a wrapper, and in this way you can also install packages there. Or what would be also nice if you want to reduce the load is building the packages on your system, installing Aptainer on your Linux at home, building it there, and then just uploading the zip file. Usually Aptainer build should switch automatically, but still, if you encounter this error, this is the way how to solve it. Then, as already introduced, you can use OpenMPI with containers, with Aptainers, and there are two options. At first, the option that is not recommended is called hybrid. There you communicate the OpenMPI version outside of the container, present on the cluster, communicates with an OpenMPI version installed on your container. In theory, this should make it easier to use it on different systems because you have OpenMPI installed on your container. But the problem is that you have to match the exact MPI version. And this can introduce a lot of hassle, so it's really not recommended. Also, you need additional dependencies for Slurm to work or InfiniBand and so on. So for now, it's not recommended to use. The other way would be binding, as already talked about. When you know where the OpenMP library is, for example, this is, for example, on Helma, which I tried. So it's defined in the OpenMPI root. So in your dev file, where you can set persistent environment variables, you set the path, you add this to your path, and you also specify where the LD library lies. And then also when you run it, you have to add the bind option that during runtime, it also knows where these files lie. So this would be then the example. You use MPI run, number of threads, and then Aptainer gets started on every instance. Then you execute some commands that you want to use and also have to bind the libraries every time. Yeah, you should also include, use InfiniBand or RDMA, the libraries inside of your container, or you bind them. Yes.
If I want to build this container on my own system,
yeah,
I would have to install, and using the same bind option, I would have to install the appropriate OpenMPI version on my system, on the host.
If you just build it, I'm not sure. But then you cannot run it on your system, which makes it a bit hard to build because you don't really know if it works. But I think just setting the environment variables, I don't know.
But it's an important question. So, I mean, let's say we user wants MPI and probably also GPUs and or cheaper.
Yeah.
I guess that wouldn't work building a platform in order. The files need to be available. So all those binds.
So during building, that's the question, what in your post section, what commands you actually use. If they, during the building up your container, so installing the programs and so on, if you then don't need OpenMPI to be present, you can build it, but you cannot run it.
But if I call like make to actually build the binary that uses the MPI library, then it would have to be there.
Yes.
And so you want to do this with environment variables to make it group, then special class and so on. And then you specify the environment variables fitting the system you want to run the container.
Yes. That's the downside of this approach. You always have to adapt your path to different clusters when you change the location or where the MPI is installed. But that's right. Also, when you compile stuff, also makes it kind of more complicated to use containers. So in this way, you should think about just putting libraries and programs that you use inside of the container, but the file that you use during building or compiling should be on your user system, because you cannot change anything that's stored inside of a container at this point. So for Python users, it's easier because you don't have to compile anything.
If I use the bind, and let's say OpenMPI root starts with /opt/OpenMPI, whatever.
Yep.
It may happen that within my default container, which I use as a base container, there's already an /opt. Would it just silently merge the two trees, or will it complain?
Replace shell.
I think binding will override this.
Remove what was.
But the point is, you can run into issues if you have, for example, no opt folder and you want to bind an opt folder. You have to also make an opt folder inside of the container.
But I can just do that. The problem is if I have something in the container that wants to be an opt, and I want to bind something from outside that's also an opt.
I don't really know for sure. Okay. So also, if you use this, be sure that it actually works. So check the NCCL performance, for example, when you use PyTorch to verify actually your results, which you should do in general if it works correctly. Then there is some light at the end of the tunnel with the MPI stuff, because in a future version of 5.0, the release will add compatibility to previous versions. So this might make the hybrid approach more easy to do. So the specific names should be standardized, but we'll see how well it works. And then thank you for your attention. And these are some sources. Obviously, we have some documentation, which was also recently updated. And on the Aptainer docs, they are very plentiful. So if you want to really deep dive, you have to look there. So questions.
What do you think how will users from, let's say, outside of this community react to all of this? Because I can imagine that a lot of them are already struggling with basic HPC stuff. And this, of course, adds a significant layer of complexity.
Yes. The point is we want to provide some recipes. For example, like we've seen with Python pip requirements installation. So we want to provide some predefined dev files to just be a drop-in replacement for using venvs. So in this way, using recipes or already predefined containers, which you don't have to change really, it could in some cases even be easier than to inform yourself about what modules are installed in a cluster and what can I do. So I would say it's a mixed bag at the end.
Okay, so the goal could be to have enough predefined containers that a lot of users can just use them.
Yes.
Don't have to care basically about it.
Yes. And I mean, there already is with Docker, you have a very big library of already established code.
Yeah, you're right, because you can use all of them.
Yes. So I think what for me personally was at the beginning a bit confusing is the storage concept. If you run your container, it looks like you are on your own home, but it's like in another OS. So that's something that needs to be communicated.
And still promise me that you just pull Docker containers and blindly map your complete home into it. Well, I find that disturbing.
Yeah, I think that's a good warning.
I mean, that's not the Docker spirit, Docker is encapsulate things.
Yeah, then you need to use the contain feature. Yeah. So that's the point. I think that the goal of Aptainer and Docker is a bit different. Aptainer, or as it's presented here now, and which is the idea, is to replace basically Python environments because they introduce a lot of errors.
This use case, but then you should rule out to some arbitrary container.
I mean, people download random Python scripts all the time from the internet and just run them on their machines. So it happens all the time, not just with containers.
I mean, even if it looks like you have root access, you have only root access inside the stuff that's in the container. So yeah. The worst case is basically you copy everything of your data in your user space somewhere, which is your own, which you should make sure that it doesn't happen. And on the other side, you cannot destroy a lot of stuff except from your own files. So, which can be bad, of course.
Yeah. Put some nice thing into the profile
So
for the next login.
take this advice of caution and only use like well-established Docker containers. From Zoom, are there some questions?
Yeah. Alireza asked, each time a Python package is desired to be installed, should one rebuild the container? If yes, wouldn't it be more practical to use overlays or mounting non-embedded images? In this way, the runtime small files can also be written into the image file. I don't know if that's possible. When the container is running, you cannot change the content of the container.
Yes and no. There is a feature called overlays. Then you can specify like additional files. And these are, again, some kind of packaged files that take everything that needs storage inside of the container. And it also looks like it is writable. But I haven't really understood the question. I think I should read it in detail. So yeah, that's an issue. So usually the idea is to everything that you want to build up and then use all the time, put it into a container, and everything that you change regularly, you have to change. Or you can build a container, your own base container, and build other containers on your base containers. That of course works. So you can use your own container as a base container. So you basically then unpack one immutable container, use its content that you have already set up, and add some other stuff. So this would work. I hope this has answered your questions. So is it possible to unpack the container, modify it, and pack it again? Yes. If I go back to the sandboxing slide, you can basically use these commands: aptainer build, sieve to container, or the other way around, sandbox container. So in this case, if you have already packed container, you can use sandbox and unpack it, do whatever you want, and pack it back. Or you use these overlays, but they are their own thing that you should read onto. Is there a way to build MPI programs without dependency to an exact MPI version? That has to answer someone who has more experience with MPI.
But that's what the MPI ABI standardization effort is for.
I think so.
Basically with an arbitrary MPI version, and since the ABI is specified, there could be a different version outside. So you don't actually care which exact version we use inside the container.
Yes. So if you use bind and you know every MPI feature you use already can work on different MPI versions, then you can try this.
As far as I understand, the containers were one of the motivations behind defining the ABI for MPI. That's one major point.
So such a container with bind is not portable anymore. You can copy it, but it can introduce problems. So yes or no. I mean, basically it's portable, but only if the binds work in the same way. Yes.